Okay, in this video we're going to take a look at tracing algorithms. Algorithms are a series of steps basically that performs a specific function. And in this case we're going to be looking at pseudocode, which is not a real language, but it sort of resembles some of the familiar languages, but has maybe a little bit more words in it than symbols. The algorithm I have on the screen here is an algorithm called largest, and it's going to take a list of n integers, and it's going to return the largest value in the list by going through each value starting at the beginning. So the word procedure tells it it's a set of statements that's going to perform something. Largest is the name, and in the parentheses here we have the inputs. The inputs are indexed a sub 1, a sub 2, all the way through a sub n, just to make it easy to refer to them and to make it generic so it can be any size n. And usually this is handled with something like an array, but you can learn about other dynamic data structures, but that's not really necessary for this lesson. The way the algorithm works is we start off by saying the max is the very first one in the list. So max gets assigned the value that's in a sub 1. And then we're going to look through the rest of the list, starting with the second one, and then the third, and then the fourth, all the way up to the last. That's what this for loop does. It says for every I from 2 to n, compare if the current value a sub I, so maybe the second one or the third one or the eighth one, is bigger than max, right? Anywhere along the list, if we find the number that's bigger than what we're currently calling max, then we make max this new bigger value. And then we move on. Now, there's no else statement here, so if you're not bigger than max, you do nothing, right? And then when this ends, we return the maximum value. So one of the things you might be asked to do is to trace an algorithm like this on paper. It's always a good idea to trace an algorithm on paper before you try to run it through a computer to make sure it's going to do what you think it is. And we'll just look a little more carefully at the components here. When you're tracing this particular largest, right, we have really that a sub 1 is 6, a sub 2 is 3, a sub 3 is 5, a sub 4 is 8, a sub 5 is 1, and a sub 6 is 2, right? We have the first, second, third, fourth, fifth, sixth element in the list. A sub 1 is the element in position 1, and so on. We always start with the largest first, right? If we've only seen one number, it's by default the largest, and then we're going to go for every value from 2 to n, comparing to see if it's bigger than the max. So when we trace through an algorithm like this on paper, we need to keep track of all of the things that get updated and all the comparisons that we do. So max is going to change, I is going to change, and this comparison right here is going to need to be tracked. So what we're going to look at when we trace an algorithm like this is set up a table like we have down here, right? Max, max, I, and a sub I greater than max. So when this algorithm starts, right, we have a sub 1 equals 6. That's the first element in the list, so max gets the value 6. Then we get over here to I equals 2. I starts at 2. And now we're going to compare a sub 2 to 6, right? Is that true? Well, in this case, right, we need to go back to our input. A sub 2 is 3. So is 3 greater than 6? The answer is no, so max stays at 6. Now we move to the third element, right? We identify that a sub 3 is 5. Is 5 greater than 6? No, so 6 is still the max. Now we get to 4, right? A sub 4 is 8. Is 8 greater than 6? Well, the answer is yes. So now the max becomes 8. Now we're at 5, right? A sub 5 is 1. 1 greater than 6? The answer is no, so max stays at 6. And then I becomes 6. Is a sub 6 is 2. Right? And now we have to ask, is 2 greater than 6? And the answer is no. At this point, I has finished going through all the values in the list. We've made it to n, so the loop is going to stop. Right? This loop is now done. So we return the value 8. 8 is the largest value in the list. Now I would imagine all of us could look at this list and see that, but we need to be able to trace it step by step on paper.